Hello students, now let's start up with the next theorem. If f belongs to R of alpha on closed interval AB, then f square also belongs to R of alpha on closed interval AB. So we know that f square is nothing but mod f whole square. See whether f is positive or negative. Mod f whole square will be again f square itself. Let small mi and capital Mi be the infimum and supremum of f on ith subinterval xi minus 1, xi, and let small mi square and capital Mi square be the infimum and supremum of f square on closed interval xi minus 1, xi. So we can take this. If mi is the infimum of f, then with no harm we can take mi square to be the infimum of f square. And similarly, if capital Mi is the supremum of f, then with no harm we can take capital Mi square to be the supremum of f square on the interval xi minus 1, xi. And let m and capital M be the infimum and supremum of f on the entire closed interval a, b. Okay. Since f belongs to R of alpha on closed interval AB, then by the condition of integrability for any epsilon positive there exists a partition P such that u of p, f, alpha minus L of p, f, alpha is less than epsilon by 2m. Name this as equation 1. See, instead of epsilon, we have taken epsilon by 2m, and you will come to know why in upcoming steps. Okay, consider u of p, f square, alpha minus L of p, f square, alpha, because I need to prove this difference is less than epsilon. If I prove this difference is less than epsilon, then by the condition of integrability we have f square belongs to R of alpha on closed interval AB. So here now consider this difference u of p, f square, alpha minus L of p, f square, alpha, which is equal to summation I equal to 1 to n capital Mi square delta alpha I by the definition of upper sum, and minus summation I equal to 1 to n small mi square into delta alpha I by the definition of lower sum. Because here mi square is the supremum of f square and small mi square is the infimum of f square. Okay, and taking this delta alpha I common in these two summation, we have this step. And using the formula a square minus b square equal to a plus b into a minus b, we have summation I equal to 1 to n mi plus mi into mi minus mi into delta alpha I. See, we know that mi plus small mi is less than or equal to capital M plus capital M. See here we know that small m, small mi, capital Mi, each and everything is less than or equal to m. So mi is less than or equal to m and small mi is less than or equal to m. So totally this is less than or equal to 2m. Okay, and if we multiply mi minus my on both sides, we have mi plus mi into mi minus mi less than or equal to 2m into mi minus mi. Name this as equation 2. And now this difference u of p, f square, alpha minus L of p, f square, alpha is less than or equal to summation I equal to 1 to n 2m into mi minus mi. See here we have taken multiplication of delta alpha I on both sides, and also we have summed up from I equal to 1 to n on both sides. So by doing that, we have summation I equal to 1 to n 2m mi minus mi into delta alpha I, and here on the left hand side we have summation I equal to 1 to n mi plus small mi into capital Mi minus small mi into delta alpha I, which is nothing but u of p comma f square comma alpha minus L of p comma f square comma alpha. So this is now less than or equal to this. And here 2m is constant. I can take this out of the summation. So 2m into summation I equal to 1 to n mi minus mi into delta alpha I. And according to the definition of upper sum and lower sum, I can write this as u of p comma f comma alpha minus L of p comma f comma alpha. So this is now less than or equal to 2m into this. And now we have taken this difference less than epsilon by 2m. So now I can write this is less than 2m into epsilon by 2m. The 2m and 2m will get cancelled. So that is why we have taken epsilon by 2m instead of epsilon. Okay. So now 2m into epsilon by 2m is equal to epsilon. Therefore, the difference between the upper sum and lower sum of f square with respect to p and alpha is less than epsilon. And therefore, f square belongs to or of alpha on closed interval AB. So this is all about the proof. Thank you.